So, who is this new kid on the block called quantum computer? Aren't supercomputers of today powerful enough to take us into the future? Or will our transistor-based friends that we have been dependent upon for decades will be replaced soon? Let's find out. Welcome back to the Fact Story. First, let's understand how quantum computers and digital computers differ from each other. The story of digital computers started back in 1947 when something called a transistor was invented, completely changing how computers worked at that time. A transistor is a fundamental building block in digital computers, acting as a switch that controls the flow of electrical signals. In a digital computer, transistors are typically used in one of two states, on or off, representing binary values of 1 or 0. Quantum computing, on the other hand, does away with transistors. Instead, it uses electrons to hold information. And these electrons are like coins that can be both heads and tails at the same time, 1 and 0, and everything in between. I loved how physicist Michio Kaku explains the difference between digital and quantum computers. He compares digital computers to solving a maze step by step, exploring every possible route at a time. Quantum computers, on the other hand, can explore all possible routes of that same maze at the same time. Here's the fun fact for you. According to some top industry researchers, we were at the same point with quantum computers in history as we were back in 1947 with digital computers, meaning things are about to get real. So, how fast are quantum computers compared to today's best supercomputers? IBM recently unveiled their latest quantum computer named Condor, which is the fastest and the most accurate of its kind. Dario Gil, the vice president of IBM, knows that we're reaching a stage where these systems can perform calculations that would take the biggest supercomputers millions of years. As quantum computers use a different way to handle information, this makes them super useful in solving complex problems in science, medicine, and more. Speaking of medicine, let's take cancer treatment for instance. Quantum computers can simulate the behavior of molecules and proteins at a level of detail that classical computers struggle to achieve. This capability is crucial for understanding the complex interactions involved in cancer development and progression. Quantum algorithms can optimize treatment plans by considering numerous variables simultaneously. This is particularly beneficial in radiation therapy, where precise and personalized treatment plans are essential to minimize damage to healthy tissues while targeting cancer cells. Quantum computers can contribute to developing more effective treatment strategies, optimizing drug dosages, and improving the overall efficiency of cancer treatment. Surely, this is one of many examples demonstrating the capability of quantum computers. This example is only one of many applications of quantum computers that can really shape our future for the better. So does it mean that digital computers will be replaced by quantum computers just like VHS cassettes with DVDs, or like landline phones with cell phones? The short answer is no, and here's why. Digital computers possess unique qualities that quantum computers will find challenging to replicate. Take data storage for instance. It remains exclusive to digital computers as the memory of quantum computers typically lasts only a few hundred microseconds. Here's another big difference between the two. Quantum computers don't give simple answers like digital computers. Digital computers are straightforward. You give it an input, the computer processes it, and you get a clear answer. But with quantum computers, it gets a bit more complicated. You provide different inputs, and instead of a clear answer, you get a range of possibilities. It's not a direct answer, but more likely an estimate of how likely different answers are. Moreover, quantum computers require absolute zero temperatures or around -450°F to be maintained. That is a substantial hurdle. The average consumer lacks the necessary infrastructure for such temperatures at home. These challenges collectively suggest that integrating quantum computers into most households or businesses is unlikely. Based on a recent report, it is predicted that we might only have around 5,000 quantum machines by 2030. This is just because it's tough to make quantum computers, store data for a long time, and it doesn't work at room temperatures. And last but not least, the real challenge is that quantum computing is very different from how regular computers work. and it will take time to fully develop and integrate into our everyday life. As a conclusion, it's likely that companies will gradually embrace quantum systems as they start to see more economical advantages. Digital computers will continue to be crucial to uphold the current way of doing things, so digital computing will still handle the majority of tasks in the industry. Quantum computing isn't going to take over the world, but it's going to have a major impact in the next decade or two by working in full concentration with digital computers. If you're liking our content so far, please don't forget to subscribe and like the video. Your small gesture of appreciation really goes a long way for a small channel like us. Until next time, ciao.